Good morning, everyone. Welcome to this edition of Cota Access, where we're going to be talking about the commercialization of space. I'm delighted to have with me Christian Lenz, the Chief Technology Officer of Capella Space. And I think this is going to be a very interesting discussion on a topic that everyone is interested in. Christian, I'd like to start by you describing your personal journey, your professional experience in this sector, and talking about how you've observed the evolution of the commercialization of space.
Yes, good morning, first of all, Sri, and thanks for giving me the opportunity to be with you, and thank you, everybody, dialing in today. It's an interesting question. So I've always been a bit of a space nut. I started out as an undergraduate coming to the United States from Germany, seeking sort of a career in space, and through some stroke of luck, I joined a student satellite project on my second day of undergrad and really have been building satellites ever since. And early on, so this was roughly 1998, I was part of a cohort of students in a number of different universities across the US and a few outside the US that were going after trying to build satellites smaller and cheaper and sort of broadening the capability that's out there. And right around the same time, there was a very influential person called Dr. Bob Twiggs, who came up with the CubeSat standard. And he started the CubeSat standard as a teaching tool for people in universities to sort of broaden, again, access to space. And that development really was important because up until that point, space had been the domain of the large aerospace contractors, had been something that happened mostly in the government domains, whether it's the Department of Defense or NASA type organizations. And bringing the CubeSat idea to more and more students allowed students to build things that previously really weren't accessible to them. And so I was kind of part of that group of people. And as I graduated, joined a small company that was trying to also provide access to space and systems slightly differently from the large aerospace contractors. And the second thing that happened around that same time is Elon Musk started SpaceX. And so he was really after trying to make access to space more available and easier and cheaper. And so now we had the confluence of more people building things for space and access to space becoming easier and lower cost. And sort of as I graduated through my undergrad and graduate degree, those people started going out into the world and realized that they could do things in space that previously couldn't be done, right? And so that created an environment in which entrepreneurs looked at sort of Elon Musk on the one side and at the people coming out of the universities and said, how do we put this together and go after novel ways to exploit space? And that was a bit of a change. And I kind of went through my career in that time frame. I worked at a small company for about 17 years, building hardware for space and doing mission designs for various customers, and both for the Air Force and for commercial systems. And towards the end of that first stint in industry, started focusing more on how do we use this newfound energy in the market to go after some of the questions that were previously in the government domain with commercial approaches. And so that's kind of how I fell into it. I started out with the weather, with going after weather data, because I thought there was a gap in weather data, and then ultimately found my way into the SAR domain with Capella, where there was a white space that needed to be filled, right? SAR data was not available commercially anywhere. It was only done in the government domain. And Capella came along saying we need to fill this gap by creating by filling that with a commercial solution.
Great. And Christian, we're going to come back and talk about what SAR is and the different types of satellite technologies that exist. But before we go there, I think a simple framing of how we think about space technologies is, I've heard this talked about in terms of, space technologies for Earth and space technologies for space, meaning what are the technologies that have applications on Earth And what are the applications? For example, people have talked about space mining, creating habitats outside of Earth, and so on. But let's stick to, space for the Earth as a simple framing of, how we think about these technologies. What are the different types of, technologies that exist over here in terms of what's your framing of the industry? How do you think about that?
So I think of the commercial space industry as the way it's generally defined is uh, space-related endeavors, activities, services, goods that are provided by private enterprises for use by commercial non-government customers, but also by government customers, right? It's private enterprises making use of space, developing solutions in space, operating those systems, and deriving products from those systems, which is different from the non-commercial space where the government would operate or procure a system, operate the system, and there might be a commercial company providing the systems, but it's really operated under the domain of a government entity. And commercial space is different from that. And there's a long history of commercial space. If we look back to space in general, right, the history of space for both the United States and outside really starts sort of in the 50s with Sputnik. And not much long after that, we had the first really commercial system in space, which was Telstar 1. It was a communication satellite that was owned, procured, and operated by AT&T, and that was in 1962. So the commercial space revolution, if you will, started not too far after the genesis of space in general. And we've had a number of these kind of steps along the way. Another big milestone was Intelsat 1, which was one of the second or third geostationary satellites launched in 1965. So I would call the telecom sector, or the first wave of commercial space, is really the telecom industry that put a number of telecom satellites in space since the 60s, and it's been very, very successful, right? Early on, it's been creating telephone links across the globe, and more recently, it's been bringing us things like Sirius XM or DirecTV. These are all commercial uses of space that have been very successful. And then I would say there's been a second wave of commercialization, which really started in 1999 when Digital Globe at the time, now Maxar, launched their first commercial Earth observation satellite, Iconos 1. And that was, again, a second part of the commercialization where now the domain of looking at Earth from space, which was traditionally part of defense and intelligence agencies, became something commercial companies could do. And that's really shifted the industry in a big way and enabled things like Google Maps, right? Google Maps was in many ways triggered by the availability of commercial data from space. And we all know how successful that's been. Now they use more than just maps from images from space, but that's been a major success story in the commercialization of space. And then as we go further towards real time today, there's things like human spaceflight, right? We've had the first suborbital commercial spaceflight by Spaceship One in 2004, the first fully orbital flight by SpaceX in 2019. And so human spaceflight is now being added to the commercialization of space. And so what we're seeing here is we're seeing different sectors in the space domain that are stepping out of the government only into commercial, and that allows all kinds of new applications and uses, and really bringing new ways of looking at what we do on Earth into many, many more hands. And so your question about how would I segment the space, there's certainly telecom, there's Earth observation, we have space transportation, broadly speaking. In that category, we have SpaceX delivering both satellites and people into space. We have a very large hardware manufacturing sector that supplies all of these companies. A new area that's coming into play is what's called space situational awareness. It's looking at the problem of what is going on in space. What are the satellites doing? What are the different actors doing with their satellites in space? It's kind of like space traffic management, if you will. And then we have a number of infrastructure services on the ground that support that entire enterprise, everything from people operating ground stations to communicate with the assets in space. A great success story here is Amazon Ground, who's deployed ground stations all around the world. But there are many other suppliers in that domain and then all the companies building software and tools to supply that industry. So commercialization of space is not really a new thing, but there has been a bit of a acceleration of that in the last couple of years. And I think that's sort of the confluence of all the different pieces falling into place, space transportation, technology, and so on.
And Christian, would you agree that, the level of specialization is increasing over time, which is that you would see probably 10 years ago these big defense contractors that would do everything. And now today, you have specialists who, let's say, for example, do only launches, or specialists who will provide satellite buses. So this probably is sort of one of the trends that you're seeing in the space industry. And I just wanted to get your thoughts on that.
Yeah, I think that certainly you can think of it in terms of specialization. I also think of it in terms of there's a much broader industry base developing. And this ties back to my original entry point of the CubeSat and SpaceX, right? There's a much larger base of skilled people who have an interest in space and have experience building things for space. They've all gone out and built small companies and have created many, many more places where there's technology and solutions that can be used to go after objectives that are related to commercial space. And so before it was kind of hidden away in the large aerospace companies. And now we have made it so easy for a recent graduate to go out and find some venture funding to come up with some new ideas how to exploit the aspects of space for applications on Earth. And we have companies in Ireland, we have companies in Scotland, we have companies all over the world who are exploiting that confluence in ways that we couldn't do before. It's become cheaper, it's become easier, and then access to space has become easier. So I wouldn't necessarily say that it's a specialization, it's a broadening of the industry base, and that's really what's exciting about this industry, right? There's so many more opportunities to do things that we couldn't do before.
And Christian, you talked about some of the applications. You talked about telecom, you talked about Earth observation, you talked about Google Maps. What are some of the interesting trends that you're seeing in terms of new applications based on, some of the new technologies that are coming to market?
So from where I sit, the sort of holy grail in Earth observation is to try to bring together as many data sets as you can to generate all Earth situational awareness, right? As there's the important thing, or why we're doing this really, is we need to understand what is happening on Earth in the different domains, and ideally we need to understand it in real time. The applications of that are broad and across multiple different sectors. It's certainly in the defense domain. We need to understand what's happening in different places, Ukraine being a great example. But there are other areas. The environmental domain is very, very important to understand what is happening to our planet. Is it happening as a result of natural phenomena? Is it happening as a result of human activity? One example is deforestations in the rainforest. Being able to monitor that and assess the impact of that has real implications for the rest of the planet. And so trying to bring this together is where this industry is going to. At the click of a button, being able to see what is happening in all places of the planet for the different scenarios that we care about.
And Christian, would you say that the highest value is really sort of integrating different data sets in terms of data points of observation? Is that where it's all coming together?
I think the value proposition depends a lot on the end user that you're talking to. Some end users might be perfectly well served with just a single data set, but a lot of end users are looking at very complex problems where they need multiple sources to substantiate the output or the information that's being generated. So as an example, illegal shipping activity or illegal fishing activity might not be something you can determine just by taking an image. You might have to bring in other pieces of data to verify that the activity is actually illegal and not something totally benign. And so it depends on the various use cases, but in general, I think there's a trend for people to wanting to aggregate these different pieces of information to get a much more clearer picture of what is happening on the planet.
Got it. Christian, talk to us a little bit about, the different types of satellite technology. You mentioned SAR, so maybe you can explain what SAR is and how it, what are the other different types of satellite technology that exist?
Certainly. So SAR stands for Synthetic Aperture Radar, and it's a method by which you use a radar in space or on an airplane, but in our case in space, to generate images and other products by transmitting a signal at the Earth and measuring the reflection that comes back from it. In our case, we can do imagery at 25 centimeters resolution, and we can do that at night. We can do it through clouds. We can do it all times of day. And that's really the one of the superpowers of SAR, that it is not limited by optical properties like weather or things that are happening on the ground or color. Another technology that has been around a little longer is electro-optical. So this is essentially putting a camera in space, often coupled with a telescope, so that we can look at the Earth also at high resolution in color. And then you add to that hyperspectral imaging, which means you're looking at it in different spectral bands that allow you to then see properties on the ground that are maybe not immediately visible in the visible spectrum. And then a third technology that is being exploited is looking at outputs of transmitters on the ground. So receive-only signals. You might be looking at things on the ground that emit some kind of radio frequency. That could be ships sending AIS signals, automatic identification signals. It could be radars on the ground, and so people want to detect where they are and what they're doing, and so you overlay this RF information with your images, with your SAR images, and you get a very clear picture of what is happening on the ground.
And Christian, as you talk about these different technologies, the level of observation of everything on Earth is increasing, right? Whether the combination of electro-optical plus SAR plus other technologies that are coming to market. Talk to us a little bit about business cases, like industry. What are the industry cases? You talked a little bit about trying to understand what's going on with illegal fishing or illegal shipping and so on. Talk to us about a few more use cases that are becoming increasingly possible with these technologies that are coming into the market beyond simple observation.
Certainly. So they're generally speaking, so not specific to SAR, right? The as I mentioned earlier, the most successful poster child of electro-optical observation is Google Maps or Google Earth. It has put the ability to get a satellite image anywhere on the planet into everyone's phones, everyone's hands. Now, that by itself wasn't possible just because of Earth observation and satellites. Everything else had to come together, but that's a super successful use case. The other cases are more in the business-to-business domain, and then also in the government domain. So speaking about the government domain first, one case that we see very actively is monitoring rainforest and deforestation for both legal and illegal purposes. And the rainforest is particularly interesting because it is usually cloudy. And so this is where SAR technology comes in and becomes very helpful. The rainforest is also very large. And so doing this on the ground is very challenging. So one of the applications with some of our customers in South America is to understand what is happening to their rainforest, who's doing what, who's doing illegal mining, who's chopping down trees to plant coca plantations and things like that. There's another application that has both commercial and government uses is flood monitoring. So when you have a flooding event, think about a hurricane hitting the southern end of the United States. It usually stays cloudy for a long time, and you need to immediately understand what is happening on the ground. And satellite technology, and particularly SAR, can help us understand where is the flooding occurring and how do we respond to those flooding events. We had a customer, an oil refinery customer, who we ran a scenario with where right after a hurricane, we were able to tell them exactly which part of the refinery had flooded, and they were able to bring the refinery back online faster as a result of some of that data. Insurance markets look at flooding and both pre and post flooding events, and Earth observation can help in those scenarios. Um, Other areas are sort of in the government domain is enforcement of environmental rules. So, for example, SAR in particular can look at oil spills and can detect oil spills and both the presence as well as the extent of oil spills. So, an operator of oil platforms may come to us as a customer and say, "Look, help us monitor our oil platforms so that we can detect an oil spill immediately when it happens, and we can respond to it and therefore protect both the environment, but also stay within our regulatory requirements." So there's various applications of Earth observations like that that become both commercially and in the government domain very important.
Got it. Christian, tell me a little bit about what are the areas that are attracting interest from venture capitalists. What technologies, what areas that are attracting both capital as well as talent?
So I'll start with the talent part. I mean, when I look at the people in my neighborhood, in our industry, a lot of people are drawn into these new startups that are trying to fill white space or areas where there isn't enough competition. Launch services is a big area. We have probably over 100 new launch services startups that are all looking at SpaceX as the poster child, and they're saying this is exciting and there's money to be made. Both in the US and in Europe, there are a number of startups in Europe. They're coming up. There's a company in Europe that's even been partially funded by Porsche, the car manufacturer. And so there's a lot of excitement around launch, a lot of competition. SpaceX certainly is the gorilla in the room, but it spawned an industry around space. There's a lot going into the Earth observation portion that we're in. There's still a lot of white space. There's areas of the visual and RF spectrum that are completely unexploited. People are going into that. But I'd say the most energy is going into figuring out ways to use all of this data and all these assets to really understand what is happening on the planet. So creating this actionable intelligence that we can use to make decisions that help us make better decisions when we do things like exploration, or when we have to look at political scenarios, or when we look at optimizing our supply chains. These are all pieces that people are looking at, and it's really about collecting the data, bringing it together, understanding it, and then more recently applying machine learning and some AI technologies to help us do this with the machines instead of with people. Traditionally, we had a lot of people looking at the outputs of the Earth observation systems, and that is not scalable. The Earth is a very large place, and if we want to have results instantly, real time, we need machines to do that. And there's a lot of progress has been made in that domain, and a lot of energy being focused on that.
Christian, on that point, the fact that there's a lot of interest and energy getting put into trying to understand, the aggregation of the different data sets and understand what's going on. Is there anything unique you need to understand about space technology, or is it just another data set that you're trying to aggregate into what you already have?
Yeah, you might be surprised by my answer. I'm a space guy, right? So my background is space, and I'm very enamored with it. But I think that space is the tool to collect the data. And people look at space, and it's maybe the flashy portion of it. But in the end, you're right. It is just other sets of data, and what they might be images, they might be locations of ships, they might be triangles of deforestation. And it's really, the key thing is there's a bunch of data. We need to apply machine learning and AI technologies to extract the information from it. And then we need to correlate it with other data sets and see how it applies to the problem that we're trying to solve. Are we trying to solve a problem of deforestation, or are we trying to solve a problem of shipping lanes, or are we trying to solve a geopolitical problems of where the tanks are? These are all things that are not really space related, but space is the tool to get us better answers.
And Christian, one question I have for you is, the evolution of space, the use of space has moved from it primarily being the domain of governments to increasingly the private sector playing a role, both in terms of creating space technologies, but also the usage of space technologies. Do you foresee a future where an individual sitting in some corner of the earth actually becomes a consumer of this data and starts doing interesting things with it.
I actually think that future is here today, right? So we have, going back to the Google Earth example, people can use that today, and it's free to go and look at things around them. Obviously, it's a limited set of information, but even the data that we're generating, or people in this industry are generating, the Maxar, Black Sky, Umbra, other companies, it's accessible to anybody today. They can come to those commercial providers and say, let me have some open data. Like in our case, Capella has an open data set that's available to anybody who's interested to see what can be done with our data. We share that data, and a smart person can use a good idea, try to pursue an idea with that data set, and maybe start a company based on that idea, and maybe develop a downstream product based on that. And that's all possible today. In fact, you can come to us and order an image from Capella of anywhere on the planet today, and you can do the same with a company called Planet and a company called Black Sky. So that future is today. What is the exciting about this is that it's the progress around data exploitation is not limited to a few people within our company or a few people within Lockheed or other places. Anyone on the planet can use this data to come up with some new solutions.
And Christian, in the few minutes we have, I would be remiss if I didn't ask you. We spent a lot of time talking about the application of space technologies, on Earth, so whether it's telecom or Google Maps or other applications. Let's spend a few minutes talking about space for space. Space mining seems to be an area of interest. Creating habitats for humanity seems to be an area of interest. Maybe just a couple of quick minutes on that.
Well, I mean, I think that's what drew me into space originally, right? That is the idea of the exploration, the going to the unknown. There's a lot of human excitement into all of this that still exists. And one of the things that is really, really cool today is that we have companies like SpaceX who are saying we're going to go to Mars, and we don't really need a business case to go to Mars. We're doing it on the basis that this is something humanity must do. And maybe there's a business case downstream somewhere, or maybe there's, like you said, mining of asteroids or mining of other planets. But I think ultimately this is still driven by the human desire for exploration. And that's exciting. It's exciting to be in this business. And a lot of people that work in this industry sort of do it because that's why they got here, even though their day job maybe is about a business case that is more focused on Earth.
Got it. Any closing thoughts, Christian, as you're on the frontier of space, not space exploration, but certainly space technologies. Any final concluding thoughts?
I think we haven't even seen the beginning of it yet. I think there's way more to come. There's been a bit of a revolution lately with SpaceX leading the way, and as I mentioned, sort of Bob Twiggs and the CubeSat invention, lighting a bit of a match in this area and lighting the fire, but it's growing. Many more applications and things are going to come out of this, and I'm super excited about that. Super excited to be in this industry, and I think really looking forward to the next 10 to 15 years of how this all plays out.
Wonderful. Thank you, Christian. That was absolutely wonderful. Thank you so much for spending time with us. And this is an exciting domain. And we're all looking forward to seeing what evolves and how it evolves. So thank you so much. I do have to put up this legal disclaimer for everyone to read before we sign off. I'll leave it on here for a minute. But Christian, thank you for everything that you're doing. We haven't talked a lot about what Capella is doing and the role that it's playing in terms of security around the world. So thank you so much for the role that you play in that and for the role that Capella plays. So with that, I'm going to sign off. This is Sri Rajan, our partner at Cota Capital. Thank you all for joining.
Thank you, Sri, for giving me the opportunity. I appreciate it.